Have you noticed that weird twilight zone right before falling asleep? Your limbs get heavy, sounds distort, and thoughts drift into strange, impossible shapes. It usually only lasts a couple of minutes before you're out cold, but some of history's most creative minds, people like Thomas Edison, Salvador Dalí, and Mary Shelley, realized this brief mental glitch was a biological loophole that allowed them to harvest ideas the waking brain simply cannot see. To understand why, look at this visualization of your brain's electrical activity. During the day, your mind runs on high-frequency beta waves, acting like a strict bouncer at the door of your consciousness. They keep you functional by aggressively filtering out random, abstract thoughts. The problem is that creative synthesis requires these scattered elements to collide. You have to bridge concepts that seem entirely unrelated. The catch is that your logical, waking brain actively suppresses that exact type of chaotic association to keep you focused on the task at hand. So how do you intentionally force that logical filter to shut down without falling fully asleep? It turns out you use a steel ball. This frequency wave chart illustrates the neurological shift that happens as you descend into the very first stage of sleep, known as hypnagogia. Notice how the rapid, erratic waking beta waves smooth out and slow down into rolling alpha and theta waves. Psychologists call this moment the loss of ego boundaries. The strict executive control of your prefrontal cortex dissolves. With that barrier removed, your mind is suddenly free to interlock abstract concepts that logic would normally keep apart. Thomas Edison knew exactly how to capture this specific state. When he reached a sticking point on a research project, he would take a nap in his armchair while holding heavy steel balls in his hands. As his brain drifted into hypnagogia, his body would naturally undergo muscle relaxation. His hands would go slack, the metal balls would crash into pans on the floor, and the loud noise would jolt him wide awake at the exact moment his subconscious was most active. He called this twilight zone his genius gap. He was deliberately riding the line of unconsciousness, letting his uninhibited brain connect dots his waking mind missed, and then snapping back to reality to document the solution. Half a century later, the surrealist painter Salvador Dalí relied on the exact same biological hack, swapping out Edison's steel balls for a heavy spoon held directly over a tin plate. Dalí referred to this as his paranoiac critical method. He aggressively suspended his waking logic so he could pull raw, hallucinatory imagery directly out of this preconscious state and translate it onto canvas. And this trick works for hard science, too. In the 19th century, chemist August Kekulé struggled to visualize the molecular structure of benzene. While dozing off, he saw a vision of an Ouroboros, a snake eating its own tail. That twilight image allowed him to finally model the chemical as a six-membered ring. Even literature's most famous monster came from this space. Mary Shelley visualized the horrifying creature of Frankenstein while caught in a vivid, semi-lucid state she described as a waking dream. So we have an inventor, a painter, a chemist, and a novelist, all relying on the exact same glitch in human consciousness. Does this mean these discoveries were just the result of lucky mechanical tricks? Or is there a measurable neurological rule governing this twilight zone? Recently, researchers at the Paris Brain Institute put this to the test. They gave over 100 volunteers a tedious, repetitive series of math problems to solve. But they secretly embedded a hidden shortcut that would allow anyone to find the answer almost instantly. This data visualization compares the success rates of the participants. The researchers discovered that spending a mere 15 seconds in the hypnagogic state actually tripled the probability that a subject would spontaneously discover the hidden shortcut. But the EEG helmets worn by the subjects revealed a crucial catch. As this graph shows, if a volunteer stayed asleep a few minutes too long, their brainwaves slowed down further into heavy delta wave deep sleep. Once that happened, the creative advantage vanished completely. This is exactly why Edison and Dalí needed to drop something heavy. The metal crashing to the floor was a perfectly timed biological safety net, designed to catch them before they fell over the edge into the dark abyss of delta sleep, where the memory of those insights is wiped clean. Most of us spent our entire lives trapped between these two extremes. We are either fully awake, with our logical filter censoring our non-obvious associations, or we are dead asleep in an amnesiac void, unable to recall the connections our minds just made. Hypnagogia suggests that the solutions to our most difficult problems are often already present within our own minds. We just have to learn how to stand on that narrow bridge between wakefulness and sleep and catch the ideas before everything fades to black.